Leonid, first question. Who are you?
I'm leading BCG Global AI Institute, which is an R&D team that focuses on exploring emerging AI technology.
Fascinating. Everyone is talking about GenAI those days, and many questions in the mind of many people. And the first one is GenAI. Is it just a repackaging of AI, or is it something which is really new?
It is new, but it's not entirely new. I would say it's an evolution of AI that we had before. Now, there has been a lot of interesting technological advances that lead us there, but I would be thinking about GenAI being part of AI. It's complementary to what we have been doing before, but it's not a replacement.
And what are the breakthroughs which have expanded the scope from AI to GenAI?
Well, there are several things that happened. So first of all, there were breakthrough in algorithms, right? This is ability to train from the data without human supervision, so-called self-supervised learning. That actually opens a lot of possibilities, because previously you need to have labels for the supervised learning, and that means human input, and that usually very expensive, very costly, and you never have enough labeled data. And so this opens it up, algorithm opens up for training for a lot of data. Then there is a new way of actually for architecture, for neural networks, the transformer models. And then there is this concept of transfer learning, which is the ability to train on one type of data, on one type of problem, and transfer that knowledge to another one. But that's on the algorithmic side. At the same time, what also made this breakthrough possible, two other factors. So first of all, it's definitely availability of lots of data. I mean, we are all created that language data on the internet, and that data has been used to train the models. But also it is the amount of compute. So the compute became cheap enough and powerful enough that we can actually train those very, very large billion-size parameters models.
So it's a real expansion of the field of AI, very clear. Can you give us extension where GenAI is bringing some impact, making a difference for companies or for consumers?
Well, at this moment, we're thinking about GenAI as being this language layer on top of other algorithms or other services. For example, we can talk about Copilot kind of scenarios. An example will be a system that helps programmers to write code, and Microsoft created the Codex and the Copilot to do this. But you can think about the Copilot concept much wider. For example, we can be talking about Copilots for mechanics or for customer service, because it's a system that will allow you to communicate with the client much better, that creates for you pretty much your talking points, or if you're a mechanic, your working actions.
And if you're a business leader, for your company, for your business, would you say this is a revolution, or is this just an evolution from what AI was doing before?
It's a tricky question. I think it depends on what business you're in, right? So if you're, say, in automotive business, or if you're in oil and gas business, for you, it's more of evolution. It's new tools that will help you to be more productive, that will help you to save costs. It will be much better, but it's not gonna completely change the way you make cars. You still need your manufacturing line, you still need to go look for oil, and you still need to produce it. But if you're in business that is information retrieval, information management business, does a lot of work with information, or if you're in a creative business, for you that is absolutely transformational, and it's happening like literally right now. And in fact, it's not only change your business, it might actually completely change your business models.
Revolution in the service industries at large, maybe?
Oh, that's also a very interesting point. Previously, our sort of traditional AI, what we have been doing for quite a while, focused on, say, manufacturing or the processes where we have structured data and very structured process. Service industry is a little bit of chaotic, a little bit based on human interaction, and a lot on natural language and unstructured data. And that was sort of outside of the boundaries of comfort for old models. Now, generative AI can be completely transformative for service type of industries.
And everyone sees the performance, what OpenAI is able to do. One question in everyone's mind is, these models, do they think or do they just compute in a way?
Well, I think this is still sort of an open question, and most of the scientists probably would say that it's still about computing, right? Because thinking or having an intelligence requires a lot of things, right? It is about being able to plan, being able to set up goals, being able to execute on those goals. So there are a lot of factors, and those models can be very, very good pretenders. So I think the jury is still out there, but most people believe that those sparks of intelligence that we see in these models are really from their infinite memory, right? And that infinite memory compensate for like sort of weak logic and reasoning abilities. And we see this in humans too. Somebody who actually has wonderful memory, he can impress everybody. And that's what I think we're seeing at this moment.
Would that be a reason why some of the critics of GenAI have said this is just a sort of stochastic parrot?
Probably yes and no. I mean, this phrase stochastic parrots came from a paper published by one of the Google researchers several years ago. And the reason for that name is because, yes, the models are really stochastic, so they generate words, in some sense, by random sampling of the distribution, probability distribution of words, and so they are random. Why they call it parrots? Well, just to sort of emphasize that they don't think, there is no logic built in, and so they can just repeat the words they've heard before, but maybe assembling them slightly different. What I think is amazing that the models are actually just trained to be those stochastic parrots, right? Only learn the language model. After some fine-tuning and adaptation, they can actually pretty good at text summarization, at question answering. They can pass tests like USMLE and other tests. Now, we still don't understand how that's happening. And, it's probably one of those very, very few cases when engineers build a system and they understand sort of each piece of the system, but they don't understand how it functions.
We've heard a lot about the size of the models and the trillions of parameters maybe that some of the latest models are working upon. Does size matter in the end or not?
Well, size always matters, but the question is, do we really need those trillion parameters? So the first success of the models came in when, the models reached those huge sizes of 175 billion parameters. In fact, that was known for many years since early 2000, and I think there was a paper that was called the unreasonable effectiveness of data, published also by Google, when they were showing that more data beats. That was not a surprise that training a larger and larger model would get more and better performance, more and more flexibility. But it was a huge surprise what those models eventually were able to do. Having said that, what we're seeing recently is that you can actually build smaller models, and smaller I mean, they're still in billion parameters size, but they're 10 times or maybe even 100 times smaller than the GPT-3 model, but they're still capable to perform many tasks, maybe 80 or 90% quality of the original models. And so the big question now is sort of, do we have an optimal model size? Maybe yes, maybe no. Jury is still out, but the smaller the model, the more accessible it. And it's more accessible not only for businesses, but also for the researchers. And it's also opened a door for open source movement because, clearly academics cannot have enough resources to run very, very large models. But if the model is of the size, several billion, and it fits on your MacBook, notebook, well, then there are many more people can use it and train it and experiment with it.
And for business leaders, does size matter? Any impact on cost? We hear a lot about energy consumption, for instance. Which model should they target?
The size of the model comes with much higher cost of the usage, right? So first of all, it costs you to build and train the model. And if you're using it as a service, of course, the model provider will charge you anyway for the expenses they occur during the model training. But then when you actually use this model, anytime you sort of use it for inference, anytime you send a request, you incur cost. And those costs accumulates very, very fast if you think about this. And that can be, very, very costly, prohibitively costly. So in some sense, there is economic in play here. And yes, sometimes you might want to have more versatile model, but it will cost you a lot. So as a business leader, I would think, first of all, like, why do you need this model? What do you need it for? And depending on that, select the model. Do you really need your model to speak to 100 languages? Do you need your model if you, for example, in telecom industry to know everything about medicine? So then, select the model that is right for you and have the right size.
And beyond cost, Leonid, everyone is talking about efficiencies or rather inefficiencies of artificial intelligence, especially regarding energy consumption. Are those models really burning a lot of energy?
If you think about those models, the 175 billion parameters, right? It's 175 10 to the ninth. It's a huge number. And it takes thousands of servers to actually run those computations. In fact, I think there are estimates saying that training a model of the size that Google trained must cost us like 10 gigawatt hours, which is, I think, like a consumption of 1,000 US households in a year. So it can be quite expensive to build those models. There is a lot of research happening right now how to make it more efficient. But it is very clear that we need to work both on engineering side of things, but also on algorithmic side of things. Because, even with the latest advances in the self-supervised learning, for a human, it's enough to show, 2-3 images to learn how to differentiate cat versus dog. For the model, we still need thousands and thousands of images to make that happen. So I think there will be more and more advances in both, algorithms and engineering part of the things to make this model useful.
To your earlier point, a bit more logic and less data maybe at some point.
Yes, in fact, I think this is a very good point, because at this moment, again, the models, they're pure statistical, right? And adding some more logic can help.
And sometimes we hear about programs, models, and sometimes we hear about agents, even autonomous agents. Can you share a bit with us perspective on agents?
Well, when we think about programs or models, usually a program or a model has like an input and an output. So you provide some information, then model operates, executes, provides you some output. When we talk about agents, this is more about the sort of interactive software, interactive program that can iteratively perform some actions and can sense the outside world based on that sort of incoming information, make certain decision, act on the outside world, collect feedback, and operate on that feedback. So it's more of, again, interactive, iterative system.
And if those systems become, as you say, iterative or interactive, any limits that we should draw as a society on what they should be doing or not doing? There's been some calls to pause research on the topic at some point.
Well, I don't think the calls to pause research are grounded. I mean, that's really, I don't think, trying to stop research in one country can prevent it from overall evolution. But there are things that we need to be careful with. Like, for example, we want to make sure that those agents cannot actually sort of improve themselves, right, without our control. So in this sense, we want to restrict this reproductive function for agents. We also need to make sure that agents are not capable of setting up sort of top goals for themselves, right, for some optimization. Like, we don't want to make sure, like, agent decides, oh yeah, we want to make somebody's happy, right? I mean, that's not the goal we want agents to be working on. So those two things, right, the fact that the agent can modify the code, that should be off the limits, and probably, setting up overarching top goals for the agents that should still remain within the human control. I think with those two restrictions, we're safe.
And beyond agents, I know you have lots of interest into embodiment. Can you tell us more about what's behind the word?
Well, it's the word speaks for itself, right? So it's providing a body to the system, and I think that the big excitement is because, the software agents we just talked about, they live in a software world. Now, we live in a physical world. And so, you're really thinking about, if you think about the sort of future and robots, well, that's an embodiment. So this is providing a model or agent capability to sense the physical world and act on the physical world. And, that opens a lot of opportunities. And, in fact, there has been a lot of discussion is whether we can ever reach artificial general intelligence without having this embodiment, without having models, experiencing the life, experiencing the world. Because, the belief is to build that in AGI, to reach to AGI, we need to make sure we have models that internally have or constructed the model of the world, which means they can predict internally how their actions and sort of what will be the consequences of their actions. And it feels like without the interaction, without like letting those models interact with the world, we'll never have enough data for them to learn about how the world works.
And I hear you say once that if we would have agents at scale, this would be a complete change in the paradigm we have for learning and collective learning.
The key there is in understanding how those models learn. I mean, we as humans, we often learn from our experience. The learnings are very personal, right? So you need to live through this to learn something. If you right now, for example, describe me how to, ski or how to play golf, I cannot go there and play golf because it's still not enough for me to learn. So you cannot transfer your knowledge from your head into my head. That's very different for software agents or for embodied agents, because over there, all the learning that has been acquired by one of the agents can be instantly transferred and shared with all the agents. So imagine how fast they can learn and how powerful that can become.
Yeah, this is all pretty fascinating, Leonid. If we think in terms of business now, for business leaders, those agents, they exist today. You've seen them in action somewhere. It's more futuristic. Where do we stand?
Well, I mean, the simplest agents, exist already right now. In fact, we can think of, creating a system, an agent that controls other software systems. There is a lot of, obviously, software used in business, and we can use agents that, for example, create configuration files that can set up, launch those programs, collect back information, analyze it, change parameters, etc., etc. You can even think about like automating, research labs with those type of agents where, the work is in inventing experiments and, doing them with different parameters. And so agents can do that. But we also see the sort of the prototypes of those agents in our daily life. You can think about, your robot vacuum cleaner that senses the world, that, acts on it, right? Cleans if it works well, collects back feedback, and learns about your house, learns about things, and that's an agent. Or, self-driving car, that's also an agent. And both of them, by the way, already have this capability of collecting data, learning from it, and then improving the big model that is later on is being sent back to them.
One reason for which the business community is a bit sometimes having reservation for the massive use of GenAI is the so-called risk of hallucination. Do they exist, really, those hallucinations, Leonid?
Well, hallucination is a sort of funny word that has been, that the researchers came up for to explain the situation when the models are actually wrong. Now, as we talked before, those models, conceptually, they're very, very similar to any other models in AI and machine learning. And so, models make mistakes. That's sort of normal. Right? You don't have a 100% accurate model. It's just when the model communicates with us in English language or natural language, we're extremely sensitive to those mistakes, right? And sort of that's what's called hallucination. Now, that's sort of, the theory. Now, in practice, those mistakes happen. So the question is, can we actually control for them? Can we come up with ways to, live with those mistakes? And the answer, to some extent, yes. So first of all, you can control it by, selecting and building the model the right way. Choose the right size of the model, choose the right training set, etc. And then you can also control for them during, the operations. So you can, for example, think about different prompt strategies, how to make this model respond the right way. For example, by providing larger and larger context, because the model really just sort of, it uses this concept to generate next point, or by, for example, asking the model to reflect on what it said, or even by setting up like ensemble of models. So sending the same question to the set of models, and the same way as you do with experts, looking for, the majority vote. Right? All of these steps that allows us to control it. But we need to understand that this hallucination is sort of inherited in technology, and we just need to live with that. Also, honestly, for some industries, that is actually not a bug; it's a feature, because this hallucination, that what allows us, what allows models to come up with some new and crazy ideas. And if you're in creative industry, that might be something you're looking for.
Yeah. Much less if maybe in the pharma business, for instance.
Yeah, but of course in the pharma or like any sort of regulated business, you don't want that.
Yeah, of course. And maybe to finish, Leonid, I heard you once explaining how we are not so sure about the representation that those models have of the world or the data they received. Can you tell us more on this notion of representation of the world for those models?
Right. So it's an open question. There are, as we just talked a few minutes ago, in order for us to reach this sort of certain level of intelligence, we expect the model to understand how our world works. For example, if I drop a glass of water on the floor, it will break down. Not the floor breaks, but the glass breaks. Or if I remove the table, glass will drop. So all those things that we call common sense, models, whether they have it or not, we don't know, right? So we never placed those knowledge into the model sort of by hand, but the models read all the papers and all the books in the world. So there is a notion that they might have acquired that knowledge by reading all that. And this is a very open research question. There are sort of arguments for it and there are arguments against it. But common belief is, in order to succeed in sort of next level of intelligence, the models have to have this world model inside.
Thank you, Leonid. This has been a fascinating conversation.
Thank you, Sylvain.